Welcome to the final day of EuroBSDcon 2014. Our speaker today is Kristaps Dzonsons, who's been, well, he's been raising hell in the Openssh for years. So take it away, Kristaps.
So I am Kristaps. This talk is actually about security. So what I thought we'd start with is how many people are developers, like actively develop software. All right, just out of curiosity, of the active development, I'm louder, of software, how many people do software that you would consider security sensitive? Everybody should be raising their hands. That's the moral of the story. Who has users of their software? That's a better question. Right? All right, so security is a problem. Okay, so who went to see Tiru's talk yesterday about security as well? All right, so we're all thinking about that, hopefully more now, given the last few months and what's happened than before. Anyway, so I just wanted to start by laying out a few assumptions or the situation in general. And which I think applies to all of us right now is number one is that you develop software, and if you don't, pretend that you develop software. And number two is that people use your software. If people don't use your software, you're in a bubble, so it doesn't really matter security per se. But this is usually the case for most of us. And if we think about this, we can really change this around to say something like this. Basically, that the software you write probably has mistakes in it, and that if people can use that, then they're probably going to be financially going for the actual resources that are on your system. So another question I could ask now is, who has written software that has been exploited in some fashion? More of you should be raising your hands. You probably just don't even know it yet. So who has administered systems that have software that has been exploited? Okay, so already there are some mistakes. Other questions. Who has written software that's never had a bug in it? All right. Who absolutely has bugs in their software right now? If you're not raising your hands, then that doesn't make any sense because There's difference
between known bugs.
Right. So whose software probably has bugs? I mean, pretty much everybody, right? So the question being, if you haven't found the bugs yet, somebody is going to. And when you fix it, you're probably going to introduce new bugs that another person is going to find. So basically, no matter what, no matter the best intentions of all of us, and generally, the intentions are quite good, we are going to have bugs in our software. And that's what this talk is about. Not so much writing perfect software, because it's never going to happen, especially when somebody like me or other normal people are writing software and we're not super geniuses. It's going to be broken. So the question is, what do we do about that? How do we accommodate for the fact that the software we write is going to be broken, and people that are using it are going to use that brokenness to take advantage of it and get to the underlying system resources. So that's my talk is bugs ex ante being a Latin term for from before, meaning bugs already exist in your system right now. So how many people are running software that they wrote on the network, on the internet? So these are the same people who are raising their hands when they said that their software certainly has bugs in it. That's it's a little scary. Of course, that's exactly what we should all expect. And the kind of theme of this talk is how to protect the system resources, meaning the machine that your software is running on, from the weakest link of the whole system, which is you. I mean, you're making mistakes. They're in your software. And if you're not making the mistakes, which you probably are, it might be in a third-party library, which you might be using voluntarily, or might just be there like in libc, which is just there. You can't do anything about it. So there are mistakes, and what do we do about it? So this is, to an attacker, which is this lovely dog right here, this is what the system looks like. There's this nice little kitty right here. It looks like true love, but it's more of an appetite thing. Your software is this thin sheet of glass right there. That's all it is. It's just, the dog is there, it's looking in on you, and you are the glass in this particular image right there. Yes, it's a little scary. So what can we do about this? This is not really the aim of this talk, but I thought I'd bring it up anyway. We could do things like write defensive code, which doesn't really have much of a meaning to it, but we'll get to it later. We could use auditors. Auditors are great. QA, flush out our bugs, right? Use up-to-date audited libraries. And you can see this is getting a little ridiculous. A language with formal underpinnings. Who's ever done that? Who has ever written a program that actually has a formal underpinning that you can do proofs? That's 2 people now in the entire room. It's a nightmare. It takes so long. It's ridiculous. You can run on systems supporting your defensive strategy. Fortunately, that's why we're here. And while we're dreaming, we can write our unicorns to work every day, because none of these things really happen. Once we adjust for expense, we take out the team of auditors. Those are expensive. We take out the QA. That's expensive. We don't audit our libraries. That's also expensive. So we're writing code now. We're using libraries. We might be using a language with formal underpinnings, and we're running on systems that are good for defense. And now when we take time out of it, because of course time is pretty much the most important thing, we lose everything else. So really all we're doing is writing code as quickly as we possibly can, making as many mistakes as we possibly can, using libraries which have been written by the same kind of people, and the best part of all this is running on systems that are concerned for us, that are there to help us, and that usually have resources to help us not make mistakes.
We lost the unicorn.
Yeah, we did. Does anybody ride a unicorn to work? No, I didn't think so. So this is a restatement again of the problem, is that usually there's not much separating us from the bad people, from the system resources, to the bad people. So here we have some nice kitty cats down here in the distance, and we have a very concerned individual up here who's just looking forward to meeting them, and is separated by about 2 stories. So that's all we really are. There's really not much separating us. And this should scare you a little bit. And I know personally, when you write a piece of software that's facing the internet, you put it on the network, and all of a sudden you start seeing hits come in from bots, from random places, and you start to think, like, it just takes one, and it's over. It's a little scary. So to restate it before we really get started, things we absolutely cannot change are economics. If people out there can benefit from invading our systems, they're going to do it because they can make money doing that. That's absolutely going to be the case no matter where you are. There's always a place where there are people who are less advantaged than us in terms of finances and who don't have as much to lose. So they're going to do it no matter what, no matter where you are. The internet is a global thing. It's going to come from wherever it comes. The second invariant, which was demonstrated earlier, is that your software is buggy. You just don't know it, but it's buggy somewhere out there. The thing that we can change, though, is the actual resources that our software can see on the system, because that's what people are after, right? They're not after our software. They don't care about our software. Our software is enabling them to get to the actual system itself. So if we think about users, aka the people who want to take advantage of us, our software and the resources themselves, we can't fix our software. We can't change the fact that users are going to take advantage of it. But what we can do is to take those resources and find a way to set them aside, to make them unreachable. And that's what this talk is about. Before I talk about what we can do now, I think it's useful to start with what people used to do. And as you'll see, or hopefully you will start to see, nothing has really changed in 40 years. That's a little scary, but it's absolutely true. So I'm going to start with a brief history of restraining our software from the system that it runs on. And it goes back to 1961. It actually probably goes back before. These are just highlights. And if anybody can think of something really awesome that systems did in terms of capabilities or permissions or segment separation back in these times, just feel free to shout it out, because it's very interesting. So let's start with CTSS. We'll talk about it very briefly. I don't want to spend too much time, but it's fabulously interesting to see people doing the same things, making the same mistakes 40 years ago, acknowledging that they made the same mistakes we do right now, and doing nothing about it. And then we do the same thing 20 years later, and then the same thing again 20 years later. Arguably, we're doing the same things now in terms of making mistakes that we did 30 years ago. And there's actually some nice text retrospectives on these systems that were written in 1975 that say things like, it's just too complicated to write a profile for security like systrace profiles. It's just too much. And anybody who's tried to write a systrace profile knows that it's just too complicated to write a systrace profile. It's the exact same criticism. Anyway, so we're going to talk about CTSS briefly, and Unix, because they're related. We'll talk about Multics, which is it's the grand security research in terms of money, at least. We're not going to talk about RC4000, but that was one of the original microkernels, which Multics, again, used in terms of its security kernel. Lamson was the guy who really defined the theory of what it means to have an access control list, which is kind of interesting. Then we have things like discretionary access control, the Bell-Lapadula model, which is basically military security. And we'll actually talk about this briefly because a lot of the way we think about security in terms of resource constraint and capabilities is derived from the military. But it's ridiculous because as regular users, we don't have any need for that. We don't think in terms of classified or top secret. We think in terms of, should I be able to open sockets? Should I be able to read files? And it's interesting that a lot of our security perspectives are driven by a method that we just don't use. We'll talk about Hydra, which is very interesting. It's the first capability system. And then a little bit more Multics. We're going to leave out everything else, including some biggies like System 38, the earlier IBM things as well. And of course, nothing after the 70s, because then there's this enormous amount of research, and we're going to ignore it for now. I've never worked on one of these, but I actually have seen one. I think at the University of Latvia, they have an old 7094 or something equivalent in its hall of attic, wherever these things go to sleep. So here we have a description from the CTSS Programmer's Guide, which is available to download, by the way, where it talks about the whole group, user, and other permission bits on a file system. This was 1965, but the system is from 1961. So 1961 is when people were using file permission bits. And interestingly, it didn't even start out having an all users bit. It was just group, which they called problem number, and programmer number, which was the user. So this goes back to 1961. People have been doing permissions for a long time. Who has screwed up permissions on their file system at some point? Yeah, that is a 50-something-year-old problem that people have been doing. And yet still, people, you fat finger it. It's incredible. I felt badly, actually, because I've done this many, 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 many times. And but at the same time, a bit of solidarity. Like, people have been doing this for 50 years. I couldn't actually find a picture of the GE 645. There were some GE 635s, but I thought Multics is really useful to talk about because a lot of the things that we think are so fancy and cool in terms of security these days were actually Multics projects. Who actually has worked on Multics? Please, anybody? All right. The system was a phenomenal waste of money, but at the same time, a lot of things that we use today were invented on it. It's very, very interesting. If anybody gets a chance, go to Tom Van Veck's website, multicians.org. It's the most interesting website out there. It's a fabulous journey through the history of computing mistakes. Tom Van Veck, very interesting. So they took this one step farther, and the whole concept of seeing everything as a file really came out of that, but they called them segments, of course, where actually memory was mapped into segments as well as files, as well as sockets, pretty much everything. And then they just enacted the same file permission bits on top of that, and boom, you have access control lists. So that's basically what this says. This is from the Protection and the Control of Information Sharing on Multics, done in 1974. As we all might know, Multics was certified as under B2 certification, the Orange Book. And this took many years for them to actually do. And the train of getting from the original Multics from the early 70s to the 1980 version of Multics that was actually certified for military security is incredible, the things they had to do to get that. And they still managed to break it all the time, is the hilarious thing. So this was supposed to be a military-grade operating system that was fully secure, and yet, we'll see, in a few slides we'll see, and yet it was broken all of the time. Not because the actual security of the system was bad, but because people just didn't want to use the resources that were available to them. They just ignored it. But we'll get to that in a few minutes. Hydra is not very well known. They ran it on a PDP-11, and Hydra was an experiment in what's called capabilities-based operating systems. We're not going to talk about the formal language like discretionary access controls or mandatory, because they're really confusing, I think, and they're not really relevant to us. We just want to have security. We don't care about the technical terms behind it really per se. But Hydra was really neat because you essentially would take all the resources that were available to software and you would put them into a sandbox, essentially. So this was where sandboxes really came out of, was in the early 70s. And of course, it was done for the exact same reason we do it today, to prevent people from shooting themselves in the foot. So it was prevent your software, which has bugs in it, from screwing the rest of the system. Or as they say it, we therefore cannot allow a single user application to commandeer the system and to the detriment of others. So this problem still exists today. This was 1975. We still have this problem today. So this is a nice picture involving two gentlemen, Paul Carger and Roger Schell. It was taken in 1984, but it's relevant to the early 70s. These were the guys who went on a mission to break into the Multic system before its certification, and they did. So these, despite all of these at the time, multi-millions of dollars that were invested into Multic security, they still managed to break into the system, not just once or twice, but left, right, and center. The final report on Multic security is really awful. I mean, it was basically wide open. And this was, again, right before the military certification, so it was in order to get that. They were kind of trying to root the system left, right, and center. So the question to ask is what went wrong? How is it that so much money was involved in these systems? So much money, I mean millions of dollars in the 70s. How is it that so many people wrote so many papers, conference talks, money, et cetera, money, and yet still the systems were just falling apart? I mean, how is that even possible? You know, here we are as BSD systems, we don't have these multi-millions that are flowing into our coffers, and they had that, and they still had problems. They still had security errors. So don't feel badly. You know, if your software doesn't quite work, if you find yourself exploited from time to time, just sit down and think, well, there were, how much was it? It was like $4 or $5 million were invested into Multics, and they still broke that too. So it's not, you know, it's nothing really to be that worried about. But what people came away from in the 70s in watching all these break-ins was to say that, and this is Jerry Salzer again saying, one, too complicated. The security the systems that already existed were too complicated and they couldn't really be audited. This sounds familiar, right? Who's ever inherited a big piece of software, looked at it and just went, mm-mm. Yeah, it's just too complicated. You just can't do it. Ingo, don't say yes, because I know you're talking about Mandoc.
No, I was rather thinking about RPC.
Yes, yeah, exactly. It's just too, you know, you look at it, your eyes start to, you think it's water, but it's blood. And it's over. You just don't want to do it, and it's never going to happen. Number two, of course, is economics. And this, I think we know even better, that it's just cheaper to do things in a privileged or administrator or super user mode because we don't have to worry about the file permissions. We can just do it like this. This we're all guilty of course, is just doing it the easy way. Of course, not me, because I'm giving the talk. Rush to get it on the air. I mean, this is the big one. And earlier, nobody batted an eye when I said, here's the ideal situation, but here's what we do because of our time constraints. And yet here we have people in 1974 saying, because of our time constraints, we're not going to do all these cool things. We're just going to do the absolute fastest. And the biggest one is lack of understanding. And that, of course, is the problem and why I'm here right now. Who knows of all of the BSD security software resources that are available to us? Who can actually label them all, from jails, systrace, WX, ASLR? They're all over the place. And some of these, like what Tito was talking about, we don't need to know about because they run in the systems themselves. We don't need to know about randomized stack gaps or these kind of inside of libc or memory. We don't need to know about that. But the things we need to do that we as developers need to write, we don't know about. And that's bad. Oh yeah, Hydra also, same exact thing. It's just too complicated. People just didn't understand what to do. They wanted to take their systems, they wanted to make them secure by using this capability system. They just didn't know how to do it. So this is a major problem, still today. We haven't talked about Unix yet, so now we're starting to get modern. All right, we're going to go from the 60s to 70s and 80s. Unix, so this is Dennis Ritchie again. First, this was a very interesting quote, and I didn't know this before. There's this kind of prevailing notion that we all have that Unix is basically Multic stripped down, yet Ritchie seems to disagree and says it's just CTSS, which of course makes sense because CTSS is Multic stripped down. So this is actually an interesting comment. As we know, the most interesting security feature on CTSS was file permissions. So we're really not talking about advanced security here. And in fact, he goes on in the same paper to say that there are several security problems. Now, this is pretty much the understatement of the century, because in the 30 or 40 years since writing this paper, there have been more than several security problems regarding Unix. I think we still had one 5 days ago. And what was the bash problem? It was 5 days ago, right? So it's several security problems. So now I'm going to really start my talk, again, for the third time. And so now we're taking a slightly different tack. We're now considering ourselves as the developers and what we can do. And this is how often we end up feeling about ourselves after our bugs have been exploited, is that we just had no idea what we were doing whatsoever. So as time goes by, what has happened since this glorious age of security research in the 70s? We're pretty much just this list. This is disregarding Linux things, which actually do manage to add several equally inscrutable things to this list. So Linux does have its own things. I'm just talking about BSD, and I'm letting Mac kind of work in there just because it shares a lot with FreeBSD, and or Darwin, or whatever we really want to call that. So here's a question. We're all aware of chmod and setuid, yes? Vaguely, okay? We all know chroot. We all know set our limits. We've all heard of jail. Who's used jail before? Okay, so we're doing okay there. Who's actually used systrace? I'm actually surprised. I thought I would be the only one raising my hand. Okay. Who's used the FreeBSD and Mac POSIX 1E facilities, the ACL and the MAC, the Mac and the ACL facilities? Who has actually used those? Who's even managed to read the man pages for those? Who started to read the man pages for those? So, okay, how many FreeBSD users are here? Okay, so none of you have actually used these incredibly powerful tools that are on your own systems. And I'll tell you why, too. I mean, we'll look at the man page and you'll see why. It's just, I mean, whatever. Okay, so KAuth on NetBSD. I threw this in there, although it's not particularly relevant just because, one, I wanted something from NetBSD. And two, it's really powerful, but there's no user-line interface. It would be good, I'm just saying, to any NetBSD people out there. I know there was some...
Yeah, the problem is that it's a bit underdocumented, that it's rather easy to get wrong.
Subsystem construction still suffers from being ad hoc, being inadequate software support for managing the program's data structures. So basically, 1978. Okay. But that's nothing to be ashamed of at all, because, again, these same mistakes, this is a tradition. I mean, that goes back to the early 1970s. So we're just following tradition that has been laid back by our forebears. KAuth is interesting. There were a lot of attempts to do jails over KAuth, even, I think, Capsicum over KAuth, but nothing really came out of it, but that's not... Sandbox init is a very useful one that's completely hidden away from view on Mac systems. Who's even heard of Sandbox or Sandbox init on Mac? Yeah, it's a tricky one, and there's no document. I mean, we'll see about this later. And the last one being Capsicum. Who's heard of Capsicum? Yeah, this one is very well marketed and very. I'll talk a lot about Capsicum. So as you can see, though, in terms of timing, there's a little bit of a break there. You know, we have about 18 years between set our limit in 4.1c BSD and jail, where basically nothing happened whatsoever. So what was happening during that time in terms of security was probably the point where we're broken in a lot, and then we tried to fix it later. And now we seem to be back at the we're broken in a lot phase. But Anyway, so we have lots of tools to use. All of these are available on BSD systems today, right now. Who has used 50% of these? 40%? 30? 20? Okay, so I think the why is a useful question, but I'm not even going to ask it because I think it's obvious. The why would be because it's hard, right? They're hard to use. I mean, and we'll see later as we talk about chmod and setuid is that they're hard. And two is lack of documentation. And we'll look at that also briefly. So let's go over these more or less one by one. And I want to briefly talk about some concepts because not all of these are the same. Obviously, we're talking about kind of different things here, and I'm lumping them all under security, but they're not all the same thing. We have three basic concepts. One is containers. I think this is what we're most familiar with. Containers are like a jail or a chroot or Sun container or Linux vServer or whatnot, where we're actually taking our worldview and constraining it to a given file system, to a given set of processes, to a given set of network interfaces. And then everybody in that jail can see the same things. So it's basically a way of containing not only a process, but maybe a user or something like this. It's very heavy-handed and very, very useful in many regards. So it's a kind of way of partitioning the system. A very different is the concept of capabilities, where we say a given process or a given user cannot see parts of its maybe contained environment. So we can use capabilities within the container. We can say, you're in your jail, but you can only see these files or only see those files. You can only access these sockets. You can only do this. You can only do that. It's a way of saying what a process is capable of or a user is capable of. And then the last one, I didn't really know what concept name to give it, so I just said labeling. Basically, access control lists. Chmod, setuid, all of these things are basically saying, you're part of this group or you're this user, thus you can do that. So it's kind of a way of capabilities with labeling. But this is the most venerable. I think at some point we've all been exposed, especially in the past few years, to privilege separation. And chmod and setuid and friends, priv dropping as well, form the bulwark of that. And I think a very nice quote, this is supposed to be the thing we should be best at because we've had it since Unix v1s. We've had this since 1971, yeah?
By the way, I fixed a bug in OpenBSD change mod last week, so...
oh, yeah, well,
we're looking at here.
So that was a 40-something-year-old concept you were just able to find bugs in. So we're all supposed to know this so well, right? We're all supposed to know you fork a process, you do all your privilege work in one, you do your sensitive work in another, you communicate over some sort of socket or something like this. And yet nobody gets this right. I mean, even probably one of the most well-known programmers and most powerful in terms of brains says it requires complicated and very detailed programming for non-trivial programs. That should terrify you. Because that's Theo the Rat saying that. I mean, I don't think, at least I, for one, am not really packing the same guns. And if somebody else who's like that says it requires complicated and very detailed programming, for me, that just says impossible. So, but doable for simple programs, which is nice. So who has ever done privilege separation? Who's actually written? Was it easy? For which programs, just out of curiosity? Okay. So you've done it for several.
Yeah.
Was it a difficult? Was it doable in simple programs, or was it required complicated and simple and very detailed programming?
I think if you build it up correctly from the beginning, it's actually doable.
So if you start,
You still can. It's easier if everything is one process, then you can just take shortcuts all the time.
Right.
But with privilege separation, you just have to. You're getting forced to do it the right way.
what if you had to start with existing code? Do you think it would have been as easy?
No.
Yeah, it's basically it's easy for us to imagine, I think is a better way of saying this. But actually doing it, do you mind if it's getting really stuffy in here? But actually doing it is an entirely... Oh, okay. Right. So essentially, this is what we should be best at. And yet, when you actually look at the history of our doing it, it's pretty complicated. I think, did anybody go to Henningstalk yesterday? you went to Henning's talk. He actually had one slide that went over the privilege separation process of, do you remember which daemon it was? Was it BGPD? Yeah, it was a whole slide with arrows everywhere and little circles and everything. It was very complicated. I saw it and I cried because it's something that we have had available to us since 1971, and it's just still very difficult to do. And that's just one of these that I'm talking about right now. Chroot is another one. Chroot never was a security mechanism. I don't know when it became one. This is the Chroot that you see right there is actually from the initial Chroot implementation. There was no security check. It just said, okay, do it. And then it was only in a 1981 commit by Bill Joy that some initial security constraints were added, so it's not trivially easy to break out of it. It was never meant to be a security mechanism. People have to stop thinking about it as a security mechanism. It's a convenience mechanism and nothing more. Set R limit. Who uses set R limit for anything but cores? For anything but ulimit C? Okay, a few people. This one is useful but very tricky, and we can talk about that briefly in a case study at the end of this. So set R limit is useful, but if somebody really gains control of your system, they can just change it back. So it's useful, but very brittle. Jail, I think, was the first big, now we're going to be serious about security, done by Paul Henningkamp. And of course, lots of people here have used jail. Jail is nice, but it's first you have to be root to run it. Second, it can be recursive. It's a nice container, but the implementation of that container is such that we don't know if there are holes in it. And I talked about this several years ago when I was doing molds. We're not going to go into it right now. For all intents and purposes, it's a great system that more people should use, but it's still not going to help you when you have two processes that are in the same jail that both need to access a similar set of files, and you don't want to have one overwrite the other. Yes?
When you say cannot be recursive, you're talking about nesting jail.
Yeah. You cannot do that. Okay, so you can run a jail from within a jail. Oh, okay. That's new in that case. Is that new?
Yeah, I think it came in actually around pre-BSD 8. It came in when they added IPv6.
Oh, okay. Well, that's great news in that case. We can scratch that one out. So jail is a useful tool, and I've always kind of liked jail because it's simple. You just run it like this. You don't need to worry about the details. And I think because we've talked so much about how complexity is hard, we should really take a look at that, not in terms of how it's done, but the fact that such a simple interface of just saying, jail me, worked. And because people are so familiar with it, obviously it worked not just in terms of utility, but that we understand it enough to just be like, oh yeah, it's a jail. And this is really useful. Systrace does not have the same benefit. So we've had a few people use Systrace. It was developed by Niels Provos. I could not remember whether it was originally done in NetBSD or OpenBSD. And I couldn't find the original commits. It was one or the other. They were both merged at roughly the same time is all I really remember. And there was a really big brouhaha in 2007 when Robert Watson found vulnerabilities in it. Using Systrace, there are two ways to use it. You can either use a userland program, Systrace1, and a policy file that says this program is allowed to do that and that, or you can do it programmatically in what can only be described as a very intricate dance. It's performance art. And we can see some examples of this if you'd like. There are also some major problems. If you're doing this programmatically, you cannot systrace yourself. You can only systrace a child or another process. And this immediately adds another level of complexity to programs where we're inheriting them. Because now we have to do the whole fork. If we're already privilege separating, then it's not so difficult. But if we're working with existing code, it can be quite hard. So again, the privilege separation complexity applies to Systrace, and that is a major problem. Other than that, Systrace, I think, is the first and really still almost only capabilities-based system that we have available to us today. Unfortunately, it's not so good for security anymore. So this is almost not even useful to talk about. I mean, if we're going to allow fork, then you're gone. So Systrace is useful, but next is POSIX, POSIX 1E. And again, this was a lot of Robert Watson's work, actually. So he really brought a tremendous amount of security information to the BSD community via trusted BSD. He brought ACL. Who uses access control lists? Not file permissions. You actually use them? Okay. Well, on the VFS. So VFS file access control list, or for other things as well?
No, it's slightly different. It's file form,
Okay.
but it's the same concept.
All right, so there are some actual users of this, which I think is interesting, because I thought there wouldn't be any. They want to move this into the next version of POSIX. Do you also use?
No, I was just going to say, actually, it's the reference about the documentation.
Huh.
Actually, look on the FreeBSD handbook, there's a section for Mac.
Yeah, it's
Yeah, it's basically you need intricate information about how your application performs, so you can actually set restrictions.
right. We'll get to this problem. So there are facilities for doing this on, but it's just FreeBSD and Darwin. The ACL3 man page is both on FreeBSD and Darwin. Set FACL, set file access control list, is something that they want to push into POSIX. I don't think it's there yet, though. There's also mandatory access controls, which nobody can really define succinctly. So it's a bit of a mystery word. But essentially, it's this whole military grades defense measures that I was talking about that were done again in the 70s, using the same people, BIBA, multi-level security, Bella Padula, that were done, of course, in the 1970s as well. So it's what's old is new again. I suggest that people look at these man pages and try to figure out what they do, because I think it's impossible. There are many of them. They're all over the place, and it doesn't really say, just do this. It says you have to know everything about your system, and you have to do this, and you have to do that. It's very complicated. And that's not necessarily bad about the writer of the documentation. It could be that the system itself is very complicated. Either way, I tried reading it all. I went through everything that was there. I finished it. I still didn't really understand it. We will talk about Sandbox and Knit, and that I'm going to hold up as a good framework that was kind of screwed up because it's Apple. Kauth I'm not going to say much about because, again, it doesn't have a user-land interface, so we can't really use it. Kauth was influenced by Mac 10.4's sandboxing, which was in turn from Trusted BSD. So Kauth was influenced, at least, by the same things we just saw. But again, I'm not going to go over it. Sandbox init is very useful. It's on your Macs. And if you want to sandbox a given process, you run one function. And that's all. And you tell that function, what do I want this process and its children to be able to do? No internet, no network, no writing, no write except temporary, and just pure computation. That's the easiest way of doing sandboxes or resource constraints that I was able to find. But it's only, of course, on Mac. And actually finding the fact that that exists was quite difficult. And we'll see, the documentation for Sandbox init is basically that. So you are basically seeing the man page right now. It's awful. A much better read for what Sandbox init does is available in the case study we'll briefly talk about because I'm running out of time, which is OpenSSH, which revealed to me what this does not do. Now, this is not available anywhere in the documentation. I have no idea how the guys who wrote the sandboxing, which we'll talk about, for OpenSSH figured out what these actually do or do not do. Maybe it was just trial and error. But it's a great interface. And I think we can learn something from it. Because really, if we think about sandboxing our programs, that's all we really care about. You know, all we want to do is set some broad limitations and then maybe fine-tune them later. But unfortunately, it's just completely undocumented, which is a problem. Capsicum is the last and probably the most complicated of all of these. Very recent work. It's also kind of hard to wrap your mind around because Capsicum is very large. And Capsicum actually requires us to think somewhat differently about Unix because we know what a descriptor is. We have file descriptors. We have file descriptors that are really sockets. Capsicum also introduces a descriptor that's for processes as well. So it kind of jams this into the whole file descriptor model, and it does that with PDFork. However, people are actually using Capsicum on FreeBSD, which makes me really happy. There's a list of them out there. You can just search through the source tree to find it, but we have bspatch, bsdiff, tcpdump, fetch, bzip2, syslogd, and so on. These are all actually using the capabilities that are available from Capsicum, which is great. So that gives me a little bit of hope. But it's really complicated to use all the same. So this is the last thing I'm going to do because I'm pretty much out of time right now. There's one program that I found that really tries to bring all of the sandboxing together that we can really learn from, and that's OpenSSH. Who's used OpenSSH sandbox mode? You all should raise your hand because you're using it by default, I think. So it's there. You are being protected every time you use SSH. That should give you this warm, nice feeling that somebody out there is really thinking, I could screw all of this up, probably going to make sure I don't do that. So they sandbox. And that's great for us as the users, but I feel badly for the people who developed this because they had to take that huge list we saw earlier and say, I need to make this portable to Linux, the BSDs. I'm sure there are other operating systems out there, I don't know. And they have to consider all of that. So actually doing sandboxing and OpenSSH, yes?
Slight correction, the OpenSSH people develop on OpenBSD and porting is done.
Right. I'm aware of that. So I'm keeping it as general as possible. So in order to do sandboxing on OpenSSH, it's about 1,000 lines to do that portably. Now think about how many bugs can live in those 1,000 lines. It's a little scary. So this is a list on, if we go to the OpenSSH source code, which we probably all have somewhere, because it's a good study, and we look at how it's actually involving sandboxing. And when they say sandbox, all they really mean is, I want to take this process and its children and disallow them access to the environment, certain parts of the environment, which from their perspective is basically everything. In order to do that properly, it took 1,000 lines. That's scary. I mean, this is, yeah?
Only
without
100
seccomp.
or 200 of them are actually running on one given system.
Right. It's for portability, yeah. So the reason we have so many is because all of these security things we talked about, you note I had written next to it which BSD it's available on. Some were OpenBSD, some were FreeBSD, some are Darwin. So in order to write a sandboxing for portable code, you have to think about all of them. And it's a little bit of a nightmare. So seccomp filters for Linux, we can disregard that. So that brings us down only to about 600 or 700 lines of code. So in terms of security, it's just a little ridiculous. And it's no wonder that in 1975, people were saying it's just too complicated to secure our own systems, simply because it really is. It takes 700 lines to do. And these guys are extremely good, too. I recommend reading the source code, by the way. It shows you what the documentation for the sandbox systems does not tell you. The methodology they use is just privilege separation. And they have to do that simply because of systrace. So systrace is the most complicated of all of these. If we look at the list that I had, so the first one, chmod and setuid, are probably the most difficult. chroot is just one command. Set our limit the same. Jail has a system call interface, but it's a container, so we're not really going to go into it. Systrace, hugely complicated. I mean, anybody who looks at the systrace man page is just, it's very long. Nobody actually understands the POSIX 1E, so anyway, kauth, also we're not going to talk about. Sandbox in it, one function, very easy. Capsicum, also slightly more complicated, but not as bad as systrace. So anyway, it just uses privilege separation, and it has to do that because of systrace. You have to look at the source yourself. It's not easy to do this. A small other case study is a program that I had written that was modeled after OpenSSH's sandbox for a CGI framework. Just as I wanted to make it really easy for myself. I wanted to have sandboxing. And still, without even including Linux, it's already almost at 1,000 lines. It will be there very soon. It's just no matter how you do it, it's going to be complicated. And this is a problem. It's a major problem. So anyway, we're now, I think, at the very close of this. So I thought I would leave you with something that doesn't really make sense anymore. It's a quote by Ken Thompson, which says, "You can't trust code that you did not totally create yourself." Who trusts their own code? You want to raise your hands. You all want to, but now you're not going to do it because of...
I at least trust my own code to not have intentional...
Yes. What's the expression about roads and good intentions? So this quote, I think, guided a lot of people in terms of how they think about security. It's the whole do-it-yourself and not invented here. But we make so many mistakes as it is that, I mean, it's ridiculous. Of course, they're not intentional mistakes. We're not intentionally trying to damage our systems, but probably our library writers are also intentionally not trying to use scanf, or they're intentionally not trying to use gets or something like this, but they might have them in there. So, this is something that we really should take away, that it's not exactly true. You can't trust yourself. How are you going to deal with that? And unfortunately, you're not going to deal with it with less than 1,000 lines. So this is my favorite picture, by the way, in the world. It's, in case you can't see it, it's a dog sitting at a computer saying, I have no idea what I'm doing. And when I was writing the 1,000 lines for sandboxing, I really felt like that. It's like, the documentation was wrong, or just so inscrutable, I had no idea what I was doing. Things just failed left and right. Trying to set our limit, actually using that to limit the number of file descriptors you have open. You don't know how many file descriptors you already have open to start very easily, so you can't just say, I want no file descriptors. Your program is going to crash like that. So it's very ponderous. So it's a bit of a downer, I know, but that's the state of affairs. Thank you.
Well, if people will sacrifice some coffee time, we could get that to some questions.
I'm wondering a bit what can be done about it. One thing is obvious. You could take code like NTPD or OpenSSH and look at it and try to do something similar. That is, for the short term, probably not that bad. Mm-hmm. But in the longer term, you want something simpler. The solution probably isn't to just invent a TENS framework. What would you say? Where should we go?
So I personally like the sandbox init concepts. I like it because it's easy. And that is, for me, is really important. I want to be able to, in a single command, basically say, I want to be able to do nothing but look at the file system. No sockets, nothing fancy, just file system. I also want to be able to say, just network, or nothing at all, because most of the stuff I do is pure computation. And I think that they got that right. Unfortunately, what that really means is a different story. What does it mean not to be able to open files or sockets? There's a lot of wiggle room there, and the documentation is very poor. Also, the moment you start to need more than that, the moment you say, I don't want any files except one, that's where we run into a major problem, because we don't have something that bridges the gap there. And I think Capabilities tries to do this by saying you can just restrict everything by default, and then you can add in little bits at a time that you want. It's really the opposite. You say what you want, and then you disallow everything else. But I think that there needs to be a lot of thought done into how to, I'm not going to say market, I'm going to say document, but I really mean market the tools that are out there already, because they're very poorly explained to the extent that it takes hours just to understand even the most basics. And usually what you end up doing is what I did. I just abandoned looking at the documentation, and I looked at what other people had done. Instead of looking at NTPD, I looked at SSH because I knew that it had a sandbox.
About NTPD, on NetBSD it runs without root privilege anymore, because it doesn't need it after all.
Right.
You just want to set the clock, and what we did is introducing a pseudo device that allows setting the clock through an IOCTL, and the file permission to the pseudo device allows NTPD to do it as an unprivileged user.
Right, and I think that that's also the easy case too, because when you think about NTPD, all it's doing is basically one thing. But a lot of the programs that we write are accessing a few files, a database usually, sockets, one or two things, either a database connection or maybe a RPC or something like this. So it's never as easy as we want it to be, but I think that the whole concept of starting with denying everything and then adding it in is useful, but it makes all of us work much harder. So Ingo, to answer your question, really, I don't know. I don't know what the good approach is. All I know is that what we're doing now didn't work before, and it still doesn't work now, because nobody's using it. If only OpenSSH and NTPD and privilege separation for a few others are really using any sort of security whatsoever, that's either we think that we're brilliant, and obviously we don't, or we just don't understand. I mean, it's one or the other. And I know that we're great, we're awesome, but our code has bugs in it. So how are we getting from, we know our code has bugs in it, to we're going to be exploited, what do we do about it? You know, we need some sort of way of connecting these. Unfortunately, I don't have a good solution right now. All I know is that the problem exists, and it's pretty significant. So we have all the tools out there. We have to make them work together.
Let's thank our speakers then.